So this is 7.1, number 34. Okay, part A asks to show that f is 1 to 1, and f of x equals so to prove that f is 1 to 1, x1 doesn't equal x2, which therefore implies that f of x1 doesn't equal f of x2. Now for part B, it's asking you to use theorem 7 to find the inverse prime at A. And for that, you know that your f of 6 is equal to 2, so then your f inverse of 2 should be equal to 6. So now you're going to use, you're going to have to find f prime of x, and you're going to have to find f of prime at 2, of the inverse. So the derivative of f of x is 1 over 2 root x minus 2, and this part is 1 over, or f of negative 1 prime 2 equals 1 over your derivative, and then you plug in the value that you get at 2 at your inverse, and you know that's 6 because of this, so you end up with f, and then derivative of 6, and you find that equals 1 over 1/4, which equals 4. That's part B. For part C, it asks to calculate the inverse of x and state the domain and range of the inverse. So you have y equals square root of x minus 2, and then you change it in terms of y, and you get x equals y squared plus 2. And now you want to change the x and y, and then you have y equals x squared plus 2, and then you have your inverse equation so far is, this is the inverse, x squared plus 2, and then you know that your domain and range are now switched, so your domain is now 0 inclusive to infinity, and the range is from 2 to infinity. Okay, and then for part D, it asks you to calculate f prime inverse of A using the formula and check with part B. So for part D, you have of x equals x squared plus 2. Now you just plug in your 2 to the inverse of x is 2x, and then you find out that f of negative 1, when you plug in 2, it'll be 2 times 2, which equals to 4, and this matches with your B. And then E is the sketch or your graphs, and then we have from 2